Chapter 8, we're going to talk about circles. So circles is our final chapter that we have together this semester. And circles are actually going to be us grabbing a bunch of things that we already know and putting it all together to graph a circle. So let's talk about the standard form of a circle. In standard form, we have a radius r and a center at h, k. And the standard form of a circle is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So if in standard form, we can quickly see the center of the circle and the radius of the circle. Let's look at an example where we have a circle that is centered at -2, 3 with a radius of 4. Now, keeping in mind our standard form of a circle, we can just fill in our values for h, k, and r. So filling in -2 for h, 3 for k, and 4 for r, we have x plus 2 quantity squared plus y minus 3 quantity squared equals 16. So if we're talking in standard form, circles are going to be nice to work with. Circles are not always going to be in standard form though. Sometimes they will be in general form. The general form of a circle is x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are just constants. Those are just numbers. Now, general form doesn't look as useful, so we want to think about if we're in general form and try to find the center and the radius. So, for example, if we were given an equation such as this, which is in general form, we would have to be able to get it into standard form in order to state the center and the radius. So we need to know how to get this into standard form. Now, we can rearrange things and get the x's together and the y's together, and it's going to look a little bit closer to standard form, but not quite just yet. But we can use something that we learned way back when we first started talking about quadratics. We can use completing the square. So back at the beginning of the semester, we talked about this when learning how to factor. In case you don't remember, here's a quick little review. If we had something like x squared minus 6x plus c, and we said what would we have to put in for c for this to be a perfect square trinomial, meaning it factors into a binomial squared, well, we would have to have b divided by 2 squared. So c would equal -6 over 2 squared. So to make it a perfect square trinomial, we'd have to add 9. And then when we do add 9, we would be able to factor this into x minus 3, the whole thing squared. Now notice this is x minus 3, and before we had squared c, we had -6 over 2. -6 over 2 is -3. So you might see a bit of a connection here, and it might help us a little bit as we start to change circles from general form into standard form. Now, let's go back to our example with our circle. This is the equation that I had given you. And I said, wait, before we can do this, we have to be able to get this into standard form. And to get it into standard form, we have to complete the square. Okay, so this is our example. We are going to regroup things, and we're going to leave a spot for adding values in. We need to add a value in with the x's to complete the square there. We need to add a value in with the y's to complete the square there. And then if we do something to one side of the equal sign, we have to do it to the other side of the equal sign. So you notice that when we're adding something in with the x's, I'm going to call that c, and we'll add that on both sides of our equal sign. When we're adding something in with the y's, we're going to call that d. We're doing it on both sides of the equal sign. Now, we actually already found c. We did that on our last slide. So we found c already. C should be equal to 9. We found that on our last slide. We're going to repeat this process again to find that d equals 4. So to find that d equals 4, we look at the coefficient for y. Not y squared, but y. As we read through here, we have 4y, so our coefficient for y is 4. We need to divide that by 2 and then square it. 4 divided by 2 is 2. 2 squared is 4. So filling in what we should have for c and for d. And then we need to simplify. We simplify the right-hand side by just combining like terms. We simplify the left-hand side by going ahead and factoring it. So when we factor the left-hand side, simplify our right-hand side, we come up with x minus 3 quantity squared plus y plus 2 quantity squared equals 4. So what this tells us is that our center is an x value of 3, a y value of negative 2, and our radius is 2. It might be helpful at this time to go back and look in your notes about completing the square from the beginning of the semester, or send me a question about completing the square, because completing the square is going to be important for moving forward with this chapter. So we have our center, we have our radius. We were able to state those easily because of the fact that we know how to complete the square. Now there are some other useful formulas that you will want to know this chapter that we've used in the past. The first one is the distance formula. The distance formula, again, is d equals the square root. All of this here is going to be underneath the square root. x2 minus x1, all squared, plus y2 minus y1, all squared. So that's our distance formula, and we have used that before. And then we also might want to use the midpoint formula. And the midpoint formula, we're adding our two x values, dividing it by 2, adding the two y values, and dividing it by 2. So we're seeing three things here that we're using from previous chapters. We're using completing the square, we're using the distance formula, and we're using the midpoint formula. Other things that you might want to make sure that you remember how to do is simplifying square roots is going to be useful here. And just working with fractions in general is going to be fairly useful. In our next example, we're told that we have a circle that's centered at 4, negative 3 that passes through negative 14, 17. Well, because we're given the center, we can state part of our equation, but we don't know the radius. Now, thinking back to some prior knowledge that you would have had from a previous math class, hopefully, the distance from the center of your circle to a point on the edge of your circle is called the radius. So if we had the distance formula, we could find the radius. So using our distance formula, we will find our radius. So here all I've done is I've plugged in the values from each of our points, and I've simplified using our distance formula, and I came up with the radius is equal to the square root of 724, which if we wanted to simplify that, that is 2 times the square root of 181. Now, we have all the information that we need in order to state the equation of our circle. We just need the center and the radius. Our center is 4, -3, and our radius is 2 square root 181. Now, because I know that in my standard form of a circle, my radius is going to be squared, I'm actually going to work with the square root of 724 before I've simplified it, because I am putting it into an equation where I know r is being squared. But if you're ever asked just to state the radius, you will want to simplify. But here we come up with an answer of x minus 4 quantity squared plus y plus 3 quantity squared equals 724. And that is the equation of this circle. Remember, whenever you're trying to state the equation of a circle, you need two things: the center and the radius. What if I told you that we had a circle with a diameter that had endpoints at -7, 4 and at 0, 5? Well, now we don't know the center and we do not know the radius. Well, we could find the center by using our midpoint formula. So using the midpoint formula with these two endpoints on the diameter, we're able to state that the center is 0 plus -7/2, 5 plus 4/2, which gives us -7/2, 9/2. Now, to find the radius. To find the radius, we would need to know the distance between the center and one of these endpoints. So I'm going to choose that second endpoint to work with just because it has a 0 in it, and I'm going to find the distance between the radius and the distance between that endpoint and the center to give me my radius. So just using the distance formula, we come up with a radius of square root of 25/2. And plugging that in to our standard form of a circle, we get the quantity x plus 7/2 squared plus the quantity y minus 9/2 squared equals 25/2. So what we're seeing is we can use this distance formula and this midpoint formula and our ability to complete the square in order to state equations of circles nicely. Now, what would it look like if we tried to graph these circles? Well, we can just use the information that we already know to draw graphs of circles. And we should be able to look at the graph of a circle and quickly state the equation. So you will be both drawing graphs this chapter and looking at graphs and stating equations. If you're asked to draw a circle centered at 2, 3 with a radius of 1, the first thing that you're going to do is you're going to plot the point for the center. And then you're going to use the radius to go out 1 in any direction. So you can go to the left, you can go up, you can go down, you can go to the right. Here I'm choosing to go to the right. And you just click on one other point using your radius, and that graphs your circle for you. Our software has a nice circle tool built into it. So you will be graphing circles on the computer. So first, click your center. Then click one point that's along the outside edge of the center. Works really nicely to just go up, down, left, or right to click on a point. Always make sure that you're going the distance of the radius. Okay, the problem comes when we're asked to draw the circle and we are given something in general form. So if we're given something in general form, we're going to have to use completing the square. Using completing the square here, we're going to work with their x's first. And we're going to say 2 divided by 2 squared. And then working with our y's, we'd say 4 divided by 2 squared. And we're going to add those numbers in on each side. So with completing the square here, again, we're using b over 2 squared. B is your coefficient of x or your coefficient of y. So with the x's, 2 over 2 is 1. Squared is 1, so we're adding 1 in on each side. With our y's, b is 4. 4 over 2 is 2. Square that, we get 4. So we're adding in 4 on each side. And then we're going to go ahead and factor and simplify our right-hand side. Then from looking at this, we're able to say that our center is -1, -2, with a radius of square root of 9, so radius of 3. At this point, it should be pretty quick to graph it. We put a point for our center, and then we click 3 out in any direction for a radius of 3. All right, one more example. Let's state the equation of the circle that is graphed below. When we're looking at this, we need to first say, okay, where is my center at? And then say, what is my radius? So first off, our center is at -2, 5. And then looking from there, we can figure out our radius, and our radius is 3. So with a center of -2, 5 and a radius of 3, we would have x plus 2 quantity squared plus y minus 5 quantity squared equals 3 squared. You could simplify that right-hand side to 9. Now your homework's going to feel pretty repetitive because there's not a ton of material in this chapter, but it is a good chapter to wrap up on as it does draw on material from all throughout the semester. So make sure you're going back and practicing your completing the square, you're practicing your distance formula, and you're practicing your midpoint formula. If you have questions, of course, hit the message instructor button and let me know that you have questions, and I am more than happy to help you. And happy studying!